Hello, this is the video about the periodic table. The periodic table was created by a man named Dmitri Mendeleev. He lived at a time where a lot was known about the elements, but nothing was known about the system of organization. So basically you had a lot of elements that you knew about, but you didn't have a thing such as the periodic table. So Mendeleev started looking for patterns. He found that there were certain groups of elements that had properties that were similar. So he started aligning these elements in vertical rows, so that means up and down, and he took these by mass number and put them from left to right. Now the mass number on the periodic table is the number located right below the symbol. So right now I'm looking at fluorine, and if you look closely at fluorine, it says 18.998. That's the mass number for fluorine. So if you notice, they start at the left-hand side and increase as you move right across the rows. So Mendeleev created a version of the periodic table that's similar to what we use today. There have been changes. So we're going to take some time now and we're going to mark up the periodic table to talk about some properties that occur in it. So first are the metals. We're going to talk about the metals. I'm going to mark them in red, so please mark up your paper as well. Now the metals are the ones that I'm outlining. Most of the metals are on the left-hand side of the periodic table. So I'm going to outline the entire left-hand side. Go across the bottom. And I'm going to go all the way. I'm going to include aluminum. I'm going to include Ga gallium. I'm going to include tin. I'm going to include bismuth and polonium. So all of these are metals. You'll also want to mark these ones at the bottom, labeled the lanthanide and the actinide series. These also are in fact metals. Okay, so metals, there are some properties that you want to think about metals. We typically think of metals as things that conduct heat and electricity well. They're malleable, which means they can be flattened into a sheet. Think about aluminum foil, right? Aluminum foil is flat. Aluminum was pounded into a sheet. And they're ductile, which means they can be made into a wire. Many metals are also shiny. And as we will learn very soon, metals lose electrons when they go through a chemical change. Okay, next we're going to talk about nonmetals. So most nonmetals are found on the right-hand side of the periodic table. So I'm going to mark these in a different color. I'm going to take my orange to mark them. And we're going to go carbon, phosphorus, selenium, iodine, radon, and everything to the right of those. Okay. So follow what I'm doing, please. Then also we're going to include hydrogen, which is in the upper left-hand corner of your periodic table. So those are our nonmetals. Okay. So some things about the nonmetals. We have this dividing zigzag line here that kind of divides the metals from the nonmetals. And we'll talk about what the ones in the middle mean in just a minute. Nonmetals don't have as consistent of properties as metals do. Most do not conduct electricity well, and they also typically gain electrons during a chemical change. Okay? We'll talk about that more in a few days. So let's talk about these ones in the middle here. I'm going to make them pink. We're going to call them metalloids or semiconductors. So these ones in the middle, and I'm just going to make these a little more obvious for you by putting a zigzag across them. Okay, the ones that I put the zigzag across, those are called metalloids, or semi-metals, or semiconductors. What they do is they have some properties of metals and some properties of nonmetals. They're very good for electronics because you can turn on and off their ability to conduct electricity. Okay, we're going to move on, but first I want you to take a moment and decide if sulfur is a metal, a metalloid, or a nonmetal. So find sulfur, the abbreviation is S. Yes, sulfur is a nonmetal. Potassium, the abbreviation for potassium is K, and in fact it is a metal. Now silicon, the abbreviation for silicon is Si, and silicon is a metalloid. The last one to practice with is krypton. Krypton has the abbreviation Kr, and that is a nonmetal. Okay, next we're going to talk about transition elements, which are also called transition metals. Okay, so we're going to go back to the metals for a moment, and I'm going to mark my transition metals in another color. I'm going to do some lines across them, like I did with the metalloids. So these are going to be our transition metals. Okay, so the transition metals include all of these that you see here. They kind of make a block here. Okay, it does include these guys on the bottom here, the lanthanides and actinide series. Just a word about the lanthanide and the actinide. If you see these spaces right here, these are where the lanthanide and the actinide series fit in. So the lanthanide series is number 57 through 70 on the periodic table, and you'll see that there's kind of this blank spot on the periodic table for that to fit. If we would put these in the periodic table would be very long and unmanageable. However, these don't occur very much in nature, if at all, and most of them are only made in labs. So we really just kind of remove them from the periodic table so that we have a more manageable arrangement. Okay, let's move on. So those are the transition metals. We're not going to deal with a lot of the transition metals too much in class, but if you take a chemistry or physics class in the future, you will. So next we're going to talk about how we can identify different elements in the periodic table. So first we're going to talk about families. So families are groups of elements found in columns within the main element section of the periodic table. So when we talk about families, we're going to talk about these columns, the up and down. So we're going to call this 1, 2. So we start at the left and we move to the right. So 1, 2. And then we skip over to boron, and above boron we'll put a 3. Above the carbon a 4. Above the nitrogen a 5. Above the oxygen a 6. Above the fluorine a 7. And above the helium an 8. So those are called groups or families. And those are the columns of the periodic table. They go from left to right along the periodic table. We also have periods of the periodic table, and the periods are labeled from the top to the bottom of the main section of the periodic table. So I'm going to label the periods over here on the left. So the periods, you can start with a number 1 next to the hydrogen, 2 next to the lithium, 3 next to the Na, 4 next to the K, 5 next to the Rb, 6 next to the CS, and 7 next to the FR. So those are periods. So I'm going to have you check a few elements, see if you can find them and label their period and their family. Feel free to pause the video if you need to. The first one's calcium. The abbreviation is Ca. If you found calcium, you probably know that it has the group number 2 and the period number 4. Let's try cesium. The abbreviation for cesium is Cs. Cesium is in group 1, period 6. Okay, next is argon. Argon you can find over here. Argon has group 8, period 3. And last, let's do nitrogen. Nitrogen is N. Nitrogen is group 5, period 2. So among these groups, we have some groups that have special properties that we want to note here. And I'm going to help you by labeling these on the periodic table with you. The first one that we're going to look at are the noble gases. Okay. The noble gases are special. They are group 8. And the noble gases are special because they do not combine with other elements. They are very stable just how they are. So these are our noble gases. The second group I would like you to mark are the alkali metals. The alkali metals are group 1, and the group 1 elements are very reactive. They don't like to be unbonded. So one example is sodium, and sodium is known to explode in water. So we're going to call these ones here the alkali metals. Next to the alkali metals are the alkaline earth metals. This is group 2. I'm going to label it above. Alkaline earth metals. And these are still very reactive, but not quite as reactive as the alkali metals. One more special group we're going to look at are the halogens. This is group 7. And halogens are also very unstable. They're very reactive, but instead of metals, they are nonmetals. So I'd like you to practice what special group do each of these belong to. So start with bromine, Br. What special group is bromine in? Yes, bromine is in the halogens. Bromine's abbreviation is Br. How about argon, Ar? Yes, argon is a noble gas. Next, let's look at barium, Ba. Okay, Ba is an alkaline earth metal. And lastly, let's look at sodium, Na. Yes, sodium is an alkali metal. Okay, this concludes the first video about the periodic table.